Okay, so let's start. It's Friday, so it's a good day, yeah? Weekend, parties. Please, yeah. Oh, nice flowers over there. Are those for me? I'm from the Netherlands, yes, so we have a lot of flowers. Flowers in America are extremely expensive. Honestly, like in the Netherlands, like let's say in the Netherlands you could have like 10 girlfriends at the same time because you would be able to afford the cost of flowers. Because the flower, like 1 rose, 2 roses, 3, 5, 10 is relatively cheap, but here what you pay here is just unbelievable amount. And then typically they're also dead within 2 days. I don't know if you have the same experience, but like very expensive. So don't do that for Valentine's Day. Buy chocolate or so, yeah, it's easier. Okay, so what we're left with is we talked about, and in class or in the lab sessions, we talked you've talked about if, else, and statement, for statements, and now what we're left with is a while statement, okay? So this is the last for and statement we did. And from the for and we now go to the while statement. So for statements, for I is 1 to 10. So I starts with 1 and then 2, 3, 4, 5, 6, 7, 8, 9, 10. And then the for statement terminates. Like a human being at one point. Yeah? A while statement might never terminate, okay? Because you have a certain operator in the heading of the while statement that might never be satisfied. Like this is an example where the while statement will terminate. So you see that on line 189 I specify a scalar variable x that value is 1. And then on line 191, and again please read all the comments that I put in the script because that explains everything, yeah, and that's why it's good to read this ahead of time. So I have a while statement on line 191 that says while x is larger than 0.01, what do? We divide x by 2. So the new x is the old x divided by 2, end. So the first time we go in this while statement, is x larger than 0.01? Yeah, this is, you have to understand that they record this for YouTube, yeah? And when there's 10 seconds silence, people are already going to watch a different movie. So you have to respond quickly, okay? As possible. So, while x is larger than 0.01, so the first time we go in that loop, or in that while statement, that is true. Because x is larger than 0.01. So this statement is true. So what do we do then? We execute what's on the next line, and that is that we divide x by 2. Now, then the new x becomes... Now, we go back to while is 0.5 larger than 0.01. Now, so we continue doing this while statement until we reach a value of x that is no longer larger than 0.01. So, for instance, I could have a while statement, like a for statement always ends, but a while statement might never end. For instance, if I comment out this line 193, so what's going on now? What do you think is going to happen? Yeah, the computer is stuck. This is a loop that will go on forever. You'll turn your computer on now, and 50 years from now it will still be in that loop, because x is always larger than 0.01. So that means while statements you have to be careful, because you can end up in a loop that never ends. Endless loop. Now, so we can actually execute this and see what happens here. So you see that there is an x value that is 0.078, and then x is no longer larger than that 0.01, so that while loop, that while end statement is terminated. Okay, so that's the way it goes. I can also, for some that really like visual effects, we can plot this to the screen. You see how this goes. You see how we start with a value of 0.5 because initially x is 1, but we divide it by 2, so then it becomes 0.5, and then at 0.25, 0.125, then etc. And then here you see at this value it terminates the loop or the while statement because no longer is this true. This is no longer true. Okay. So here, all the explanation is in the comments. Yeah, you can read this. Yeah, please read this. Everything is relatively is more or less explained. Now, we can also do other things with while statements. For instance, we can compare two numbers with each other, and we can keep changing those numbers until they're smaller than a certain convergence criteria, which is in this case called delta, okay? So imagine that I define that I have an R value of 10 and an R old value of 0, so I take the absolute value of that difference. So in the first case, the first time I go in this while statement, that value is 10, and that is larger than delta. And then what I do here, I calculate a new R. First of all, I set the current R to be R old, and I calculate a new R. Okay, and I keep doing this until the difference between R old and R is smaller than that delta value. Okay, so we can also display this result. We'll just here. And now I have R is 3.1623. And what does this actually do? It calculates, I think this is the square root of 10. Yeah, it calculates, this is a very simple script here, what you have here, to calculate the square root of a number, an approximation. Okay? And you want that approximation. Oh, someone left a dime for me. Wow, that's my salary increase this year. So what this while statement does is it approximates the square root of the number 10. And that R old is just some initial value. Okay, and 0 is a good value. So this while statement is just a simple algorithmic rule here to compute the square root of a given number. For instance, this is in the book, we can change this value to, now what's the square root of 16? Yes, that was within the 5 seconds. Good. Oh, did I do this correct? I keep getting R is 16. Interesting. Oh, here, no, sorry. I keep changing the wrong name. I have to change this X value. So R, here we go. Nou ja, 4. Nou ja, that's the square root of 16. So you can use these while statements to update R old, and you get an estimate of the square root of a number. Now here, this is what we essentially did. R was 4, and the square root of x was also 4. So ultimately, you have a good approximation, okay, if it's 10. Now, imagine you want to do the same thing with the while statement, but you want to make sure that you're not ending up in a loop that never ends. Yeah? Because that's just a loss of time, okay? So what you can do is you're not only adding the first statement, you have the first statement like what we had before, while that absolute difference between those two numbers is larger than delta, you have another statement after it and an AND operator that says, I do not want to do more iterations than my maximum number of iterations. So in this case, what I defined on line 236, I said, I want to do a maximum of 5 iterations. And each time I'm going through this, I update my iteration counter, okay? And I don't want to do this more than 5 times, because I have defined that to avoid getting stuck in a while loop that never ends. Now, yeah, you can execute this, because this will only be true if both of them are true. So I cannot, if my iteration becomes larger than my maximum number of iterations, even though this gets smaller, I'm not going to continue, because this last statement will not be true and you will stop. So we can define this, and we'll start with the number 20. We like to know the square root of the number 20, and we can see how many iterations. Oh, 0 iterations. Why is that? Oh, did I actually execute? Control C, iterate. Oh, 0. I don't know what's wrong with my MATLAB today. Oh, R old. Let's see, delta. See, that's how I program, yeah? This is how you learn how to program. So, let's see, where are we? We're over here. So we'll just copy paste this. And we'll see what's R old. So now I've done 4 iterations. So sometimes just clear the memory with MATLAB, because I've done prior to class, I do other things, okay? So the memory might be full with other variables, might be confusing. But anyway, what happened in this case, I needed 4 iterations to calculate the square root of the number 20. Okay, and what is the square root of that number? Is 4.4721. I got 4.4762, which is pretty close. And one of our TAs, and what you can see here also is how good is my approximation. And you see this is a reasonable approximation error. Anyway, one of the TAs posted questions that you can expect next week on the first exam, okay, online. I highly recommend that you do those. The answers are also there. Okay? If you're able to do those successfully, you'll do okay. Okay, now, anyway, there is more if while statements that you can do. There's all kind of variants. You can do a while statement, and in that while statement you can do an if statement, etc., etc., etc. So there's all kind of different variations. The thing that I like you to be aware of is a difference between 2 different commands. That's the break and the return command. Okay? So, I've written a function for you. Here at the end, edit example 5. This is a function I wrote. So this function takes some value as input, an n. The name is example underscore 5, that's the name of the function, and it returns a value of y. Now the first thing I do is, based on n, I create a horizontal vector with random values between 0 and 1. Okay? And then what I do is, I initialize a scalar, I say that scalar value is 1. And then what I say, as long as this value of I is smaller than my n, so imagine that n is 10, then I define that y is xi, so y becomes the index of this random vector, and I update my I value, okay? And then what I add on top, that if my y value that I get here is smaller than 0.5, I return. Okay, and this is important. What is return? Return means that you leave the function immediately. Okay, so no matter where you place a return statement, as soon as you reach that return statement, you go back to the top of the function and you return the y values that you have in this case. That is what a return statement does. Okay? And a return statement is different from a break statement. If I put in a break statement here, then this while loop will continue. It will just have broken over here, but then it will continue upwards again to the top to see if while, as long as I is smaller than n, it will continue this loop. And then at the end, it will compute 100 times the sinus of y. That becomes the new y. So the difference between a return and a break statement is that the return statement immediately puts you back to the header of your function, whereas a break statement will break the if-else-end statement of the for loop or the while loop, but it will continue the calculation. It will just break that particular calculation. And we can see the difference here. If I define a value of n, like let's define a value of 10, now I have some y value. Yeah, y is 0.1266. That was my function. Okay? If I make this a break statement, what you probably see that my y value is much bigger because I have a multiplication here. Now this line is executed, which otherwise is not executed with a return statement. So if I do the same thing, you now see that it's 23.45. Okay, so important difference between in a return statement, this line is not executed because as soon as the function file hits return, it goes back immediately to the function header and it goes out of the function. Okay, but with the break statement, it will continue doing the loop until it's done and then execute whatever else is left in the function. So I'll leave it to return. Okay, so that's for lecture 5. And again, please, 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 I keep saying this, but it's really important. Look at these scripts, okay, in detail. They summarize the book. I try to help you as much as we can by summarizing what's in the book, that you don't really need the book, okay? But I cannot cover everything that's in the book in great detail. I wish I could, but unfortunately you guys need to learn 800 pages of boring MATLAB. Okay? Now, what are we supposed to do today? Factorization. So factorization versus scalar calculation, pre-allocating memory, how to work with logical operators, which you now know. Logical operators are and, or, not. Those are the 3 logical operators, yeah? The find function, the use of global variables and the inline and the eval functions. Those are all built-in functions, okay? And I typically start with clearing the memory. I didn't do that today, but let's just do that now. We clear. So now I typically do clear all and then CLC. So now we have nothing in the memory. Everything is gone, okay? So now we start. Okay, so the first thing that I show here is the effect of factorization. What does factorization mean? That means that MATLAB immediately does the same thing for each index in a vector, instead of doing it using a for loop, that you do it one after the other. And an example is given here. I define a variable dx. That's my step bend in the x direction, and that's pi divided by 30. Then if I divide the number of x values that I have is 1 plus 2 times pi divided by dx. Then what I do, I write a for loop where I write for I is my counter, is 1 to the number of x values, and I say that xi is equal to I minus 1 times dx. dx is a scalar value that we calculated here, is pi divided by 30. and yi is the sine of 3 times xi. Okay? So essentially what I do, I create here x versus y. So let's see what dx is. We can compute dx. So dx is some small value, is pi. This is pi, and we divide that by 30. So we get dx, yeah, that's dx. Then I defined number of x values that I want, is 61 in this case. And then I do a for loop, where I loop from 1 to 61. So x1 is 1 minus 1 is 0. Times dx is 0. So x1 is 0. y1 is the sinus of 3 times x1, and x1 was 0. So the sinus of 3 times 0 is the sinus of 0 is, or the sine of 0 is. So yeah, so we have x1 is 0, y1 should be 0. Now that's how you do your entire loop. And we can do this quickly like this, and then we can plot this. And we get a nice plot here. Let me move this away. This is my plot. And then obviously we like to have some nice labels associated with it here. X value, y value. And I plotted here 3 times the sinus of x. The sine of x, yeah? That's what I believe I did. What did I plot here? Yeah, 3 times the value of xi, that's what is plotted. And the sine of that. Okay, now, this is a for and loop. So this I need to do 61 times. Okay, so MATLAB needs to do this 61 times, okay? So it takes a lot of time. So, maybe we can do this faster, and indeed we can. We can use factorization. The first thing we do is we define x to be between 0 and 2 times pi with the step distance of dx, which was pi divided by 30, yeah? So this is how we can define a vector. So we immediately get something like this. Okay, we have 61 values now of x, so that's one statement. Then what I define, that y is simply 3 times x. Okay, and the sine of that, okay? And then, hold on. And then I get the same result. Now I hold on because I want to plot over my previous plot. And now I use blue plus symbols. So this is where you now see the difference between a for calculation, like if you do it this way in a for loop, and a factorization, where you do this immediately. And MATLAB is especially designed for matrix and vector calculation. Okay? So if you do it the way it's done on line 39 to 41, you'll get the best efficiency. So speed-wise, like this is really simple, but we work with models that requires hours to run. Imagine you want to predict the weather for the rest of the world tomorrow at the very high resolution. Those models don't run instantly. They need a lot of running time. Okay? So that's why you need to be as efficient as possible. So we prefer vector calculation, where instead of doing it element by element, I is 1, I is 2, I is 3, I is 4, you can do it with one statement after you defined your x values. Now this we can, you can look at it at home. Memory allocation. Now let me give you an example here. Okay? So imagine that you have a data set and you want to fill that with numbers, some random numbers, because that's important. Your teacher told you to write down 25,000 numbers. Okay? And so you are like, okay, and the teacher told you it needs to be uniform random numbers between 0 and 1. So we can write a for loop for this, yeah? We could say, forget about the tick, okay? That's what you have when you are a professor, yeah? You write a for loop for y is 1 to 25,000, where you state x I, comma 1, which means like you're filling a column, a first column with number 1 all the way to 25,000 with a random number. Okay? What I just like to show here, that again I clear everything here, that this takes 0.2881 seconds. So now I have a variable x that's 25,000 by 1, and I can plot that x thing, and it looks like this. Yeah, you get a lot of values here. Each value is plotted here. We have 25,000 values, and that's between 0 and 1, yeah? Lots of values, okay. Now you saw the time it took. Now we clear this. Now it turns out that you can do this calculation much faster if you pre-allocate the memory, which means that instead of adding row after row after row or column after column after column, you initially define the size of the vector of matrix that you're expecting. Now we clear this thing here, yeah? We clear. And I know that I'm expecting something that's of size 25,000 by 1. And I initially pre-allocate the memory with values of zeros. We know the zeros comment by now. So x now, if I execute this, I have nothing than 0. So if I plot x, I see nothing than nothing here. Everything is 0. Yeah, I have 25,000 values. You see here you have 25,000 values and they're all 0. So I pre-allocated the memory of x with value of 0. And now I do the same calculation as I did previously. And you now see that it's much faster. Okay, previously it was 0.28 seconds and now it's 0.0036 seconds. And you might think, okay, this is marginal, and I agree with you, this is an example where the difference is marginal. But I cannot give you an example that takes 45 minutes, okay? But I can guarantee you that we have many programs where if you pre-allocate the memory, that things are going way, way faster. So essentially what we did here in this second case is we just said, hey, you know what? We know the size of x, and conveniently we just define x already, and we define it to be of size 25,000 by 1, and we just fill it conveniently with zeros. In this loop, we replace those values of zeros with a random number between 0 and 1. And this is faster than the other approach here, because here MATLAB doesn't know what the size of x is. It starts with 1 and then it adds another row, another row, another row, another row, and each time it adds another row, it needs to update the size of the memory in the memory, and that takes time. I can give you really bad examples where things take hours and hours, which otherwise you can just run in a few seconds. And again, everything is explained in the text, yeah? Please read the text. Now, logical operators, okay? Now, we know logical operators is larger, or what is logical again? And, or like, I think this is relational, these are logicals here. So here, let's give you an example here. Is I have an x vector and I have a y vector, okay? And this is confusing to most people, okay? So look carefully what MATLAB can do here, okay? So I have a vector of x and I have a vector of y values, okay? And they're both of the same size, yeah? We can see that. Both have 1 row, 5 columns. Okay, and now what I request is a new variable, z, and that is x between round brackets y. Okay, and what the heck is going to happen now? Now let's see. This is going to happen. And do we understand this? So C1 is x, y. C1 is x, 5. Do we see that? My first element of C is x, 5, because y element number 1 is 5. My second element of C is x4, which is 40. My third element is x3, is 30. My fourth element of C is x2, is 20. My last element is x1. So MATLAB can be extremely powerful, and these are just things to show to you that you have to practice with. These are just operations that in other languages you cannot do so quickly. You have to write a for loop. But in MATLAB you can immediately do things like this. Okay, so you can imagine that if you look at MATLAB scripts, that can be pretty confusing if you have a lot of statements like this, that you're like, what's going on here? Okay? So please study this at home. So here, I've written this out here, yeah? Now, we know now what a statement like this, what's the answer here? I hear 0. It's actually 1. So pi is smaller than the square root of 10. Yeah? So that's y is 1. If a relational operator, if that's true, then the answer is 1. If it's not true, it's 0. Yeah, we've seen these operators by now, yeah? At least in your homework. Okay. Now, the find function, or I can, let's do the same with matrices, okay? Okay, so we'll have an example here. I create a matrix here with 5 rows, 5 columns. And imagine that I'm interested to know which elements of this matrix have a value that are larger than 0.5. Now, again, MATLAB has a very simple statement that I can execute, and it's just this statement. I can do R larger than 0.5, and it will return a matrix the same as the size of your original matrix here, which was 5 by 5, and for each element it will check, is this element larger than 0.5? Answer, is that true, that operator? Yes, it's a 1. In this case, that's not true, it becomes a 0. In this case, not true, 0. In this case, this number is larger than 0.5, it becomes a 1. So MATLAB has these nice built-in functionalities that are very useful. Now, for those that don't believe this, you can do the same thing in a for loop. But then you need this type of for loop, okay, where I loop over the columns, I loop over the rows, and then I figure out if that value of R is larger than 0.5. If it's true, then I return a value of 1. If it's not, I return a value of 0. So this is what we call a double for loop, because I loop for I is 1 to 5. So in this case I loop over the rows, then for j is 1 to 5 I loop over the columns, and then I state if Ri, j is larger than 0.5. Now we're on line 113, I believe, yeah? If that's the case, then I have a matrix F, I, j is 1. If Ri, j is not larger than 0.5, that Fi, j value is 0. So I have two counters here. I have a counter I and I have a counter j. I from 1 to 5, j from 1 to 5, because my matrix is 5 by 5. Okay? So here I first loop over the rows, because you see here Ri, that's the row indicator, and then j is the column indicator. So how does this loop go in practice? MATLAB goes in this loop, I is 1. Then it will do the entire inner loop. This is called the inner loop. This is called the outer loop. Okay? So I is 1 is the outer loop. Then we go to the inner loop. And then we will go all the way from 1 through 5. So the first thing we do is, if R1, 1 is larger than 0.5, then F1, 1 is 1, else F1, 1 is 0. Then if R1, 2 is larger than 0.5, if R1, 3, 1, 4, 1, 5. So that's what's going on, okay? As soon as you're at the last column 5, you go back to the outer loop and you update I from 1 to 2. And then we have, for J is 1 through 5, for I is 2. So this is the same procedure here as this simple statement. And that's why many people like MATLAB, because in many other coding languages you would have to write this, whereas in MATLAB you can do it with one statement, this statement. Okay. Now here there's another example here. Now, we have a find function in MATLAB. And let me create a new matrix that's 5 by 6 for an example here. I can with random numbers. Somehow I like random numbers. That defines my life a little bit. It's entirely random. Like last night I went to bed at 10:30, really early. I woke up at 12:30 or so. And I thought I had to go to the hospital, which a doctor looking at me would say that would be a smart thing to do. But I woke up, I need to do a back surgery. I need to do a back surgery. And I was like 12:30 and I was waking up, back surgery. And I was thinking I was back in the Netherlands with my parents. And suddenly I realized, oh, my parents aren't around. How am I going to get to the hospital, yeah? So I was going to go through all these ideas. And suddenly I decided at 12:45, let's just wake up. And let's just work. So then I worked till 4 a.m., yeah? And of course under the influence of lots of alcohol and other nice things, yeah, because those keep you really awake. And then I fell asleep, and then suddenly, like at 7 a.m. I woke up again, and then I had the feeling that somehow I had to go to the hospital again. I don't know what it is. What teaching does really strange things with the person, you know. Anyway, makes you realize all the things you're not good at, which is in my case is a lot. So imagine that we create a matrix A, which is random with 5 rows, 6 columns. So again, A is name of the function, rand built in, bracket open, round, number of columns, number of rows, comma, number of columns. Okay, so we have 5 by 6. Now, again, I can do this statement. I want to know all those elements that are larger than 0.5. A 0 means that's not true. A 1 means that value is larger than 0.5. And if you don't believe me, I can also change this to like 0.75 and then 0.95. And you see, unfortunately, nothing is larger than 0.95 anymore. And we could figure that out. If we do the max of A, we'll get the max of each column, and then we can take the max of the max, and then you see that 0.9413 is the maximum of all the numbers in our matrix. Okay, but that's for later. We can also this way figure out what's the overall minimum value, and we get to almost 0. Okay, so obviously in this case, I just have, I don't assign a variable, I just print this to the screen. But I can also use the find function. Welcome. You want me to repeat what you missed, or? No, okay. No, just kidding. I hope it was a good conversation.
It's about a new job.
New job?
Uh-huh.
Oh, that's important.
Yes.
That's why you're sitting here, yeah?
Yes.
That's, okay, no, nice. You want to share, or no? Okay, so find. Some students like to share. It's really interesting because, you know, on YouTube nowadays you can become very famous, yeah? If you say you have some really exotic job, some people might like it.
It's doing AutoCAD work, if that's exciting.
AutoCAD. Oh yeah, so yeah. Yeah, so she's going to travel. Okay. I don't know what that is actually. Yeah, the sad thing is, so you're teaching in engineering, yeah? But I'm not an engineer at all. No, seriously, so you apply for the job at one point in your life, you just did, yeah? And they call you, and then they actually have to show up, and then they have to answer questions. They ask you questions like, what's your name, what's your day of birth, and all that, yeah? So I wrote that all down, because you never know when you forget, yeah? So I wrote it all down. So finally I ended up being hired, and I was hired by an institute, and then the dean of engineering thought, yeah, we'll place this person in engineering, because all the other deans thought like, oh, this guy we certainly don't want to have. So I ended up in engineering, and then they place you in a certain group. Then I was placed in what they call the hydrology group, whereas I'd never had a hydrology course. Yeah. And the things I publish on range from birds to like geophysics to all kind of things. And some of my papers are about hydrology, but there's nothing I know about hydrology, because the only thing I do is write these MATLAB codes that people use. Yeah, that's how sad. And then you end up teaching this course. Yeah, that's interesting. Yeah. So whatever you do in life, don't do it really good. Now, I always tell my students, you know, when you write really good scientific papers and you become really known, people start emailing you, they start calling you, start winning awards, they all want you for something, yeah? You become editor of a journal, it all takes your time. Whether if you're just a really bad scientist, no one cares about you. Yeah? So that's why all my students, they have a great life. I tell them just to write down nonsense, which is fine by itself. But there's a find function here, which those recruiters also use, the find function. That's how they got to you probably. And the find function tells you the indices, the index of the location where your value in this case is larger than 0.5. So we have a matrix A, and now this I value, what I asked for here, yeah, is a vector that tells me at what places in my matrix A is my value larger than 0.5. And remember, we're always used that a matrix has rows, columns. The find function doesn't use that. Find doesn't return row, column. It just returns a number. And why is that? The way the find function works, if we have A, is it goes top from it starts left corner here in the top, it goes down. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17. All the way, this is 25. And you see that 25 is the last element of I, and indeed this number is still larger than 0.5, whereas number 26, 27, 28, 29, 30 are not larger than 0.5. So when you use the find function with the matrix, it returns an index of your matrix. Okay? So the counting codes, yeah, column-wise, yeah? One column after the other. That's the way the counting goes. Again, read the scripts and everything is reset. Now, what the nice thing is that sometimes you don't like values that are larger than 0.5. Yeah? So now I have identified which values those are. Yeah, so this was my original A. And now what I can say is you know what, those values of I that were smaller than or larger than 0.5, you know what I do? I just assign them a value of 1. And this is what you get then. Then you say the I is 1. So again, this is vector operation. A is a matrix, I is a vector. And you just say that all the values, all those indices that have a value larger than 0.5, I reset them to 1. And that's what you see. Now all those values have become 1, whereas the other ones are not touched. So, now, global variables. Okay, so sometimes, remember in a script, we have a function, yeah? And I have a function here for you, example 6. Okay? So this is a function here that I wrote. It's very simple. This function has two input variables that are both scalars, m and n. And the only thing it does, it generates a matrix of size m rows by n columns with random values. That's what it returns, and that variable is called y. Okay? So to execute this function, I will need to do something like, I need to define these numbers like 3 and 4. Yeah, now I have something that's 3 rows, 4 columns. Very ideal. Sometimes in life, it happens to you that you are really not wanting to specify all the input variables to a function. Because certain input variables, you have a script that consists of 10,000 functions, and all those functions use the same input variables, or at least a few. Then MATLAB has an option that is called a global variable. Okay? And what does a global variable mean? That's a variable that's known everywhere in the program, and you don't have to specify it. So in other words, in this case, I had to specify my two input variables, yeah? 3 and 4. Number of rows, number of columns, function name. And this is what it returns. Okay. But imagine that I really do not like that I have to specify the number of columns. Yeah? Now what I can do is I can say global, in this case n. N has now become a global variable. And what does that mean? That if prior to this script here, I define n in my main script to also be a global variable, so in my main script I now define global n. Okay, so now I execute this statement. Global n. And then I specify that that global variable has a value of 10. Now I can execute this. And I have my y2 without specifying what my n value is. Because in this function edit example 6 global.m, what you see here is that n value is a global variable. So prior to executing the function, you ask the program, I know that n is a global variable, and you ask global n. And as soon as you execute that statement, this function knows what the value of n is. Because a function only knows the values in that function that are actually specified in the header. And in the header in this case, we only specified m. We didn't specify n. Okay, before we leave, a few important remarks, okay? Please study the scripts that I sent. The exam next week is exam 1. Will count for 20% of the score. Okay? Will be in part multiple choice, will also be open questions. And the way that works is that there's a question, you have to program something, you have to plot something to the screen, or you have to get you have to give a certain answer. Then you raise your hand, then the TA will come and check your answer. If it's wrong, you have 2 additional attempts to get it right. So the TA will tell you if it's right or if it's wrong. He's not going to tell you, yeah, it's wrong because on line this and this you have to change this and this and this and this. Okay? So you have 3 attempts. Once it's right, he will give you the desired, you have a markup, he will give you the point. So it's part multiple choice, part open. So you're allowed to use MATLAB, that's the only thing. That's A, what I wanted to say. Second thing I wanted to say is that I'm not able to cover everything in class. Next week and afterwards, yes, but not until now, okay? It's too much and it's too overwhelming, okay? So, study these scripts at home. I put a lot of effort in writing these scripts in the comments to explain why something is done a certain way. Read that, work with it, yeah? Practice at home. That's the only way that you're going to learn how to program. Practice, change numbers, try to write something yourself. See if you understand it, like this global thing. Write your own functions. See if you understand it. So do not expect that we're limited to what I discussed in class. Study all the scripts up to today, so including today, will be covered next week during the exam, okay? Very important. If you have questions, the third thing, the TA posted an example exam for you to practice. Answers are also there. Okay? If you have questions, you can write the TAs, you can write me. We're trying to do our best. We're trying to accommodate all of you, but we can only do so much. So please understand, okay? But the only way to learn how to program is to just actually do it. If you see me do it, it's like, oh, I can do it. But no, do it yourself. I also make mistakes all the time. But not only with programming, that's my entire life, okay? Nice flowers, by the way. So, nice weekend.